Hello friends, today I am going to discuss model for forecastings. So model for forecasting means forecasting like a grossly translated as the task of predicting the future, and it has been presented in the human society for ages. So whether it is thought fortune tellers, weather forecast or algorithmic stock trading, mean has always been interested in predicting and what the future hold. So here forecasting is the future, not easy. So consider fortune teller forecast like a stock market guru or weather forecasters. Many try to predict the future, but few succeeds. So and for those who succeed, you will never know whether it was luck or skill. So in a recent year, the computing power of computers had become a much more commonly available. So now we are at present just a great boom in we use like artificial intelligence, and especially a machine learning can be used for a wide range of tasks including robotics and self-driving car, but also forecasting. That is, if you have a reasonable amount of data but the past that you can project into the future. So let's try to learn machine learning techniques that are relevant for forecastings. So I will present a large number of the machine learning submodels together and with the intuitive explain of the model. So it's a mathematics, it's an applied use cases. So the main goal is to give a real insight into the applications of those machine learning models. So let's see. In this book, I am going to create like some approach like a time series approach. So first I am going to import a pandas as PD and import matplotlib.pyplot. These two are the most important library, and I am creating a data like this, and this data is a we see like a years and price. So its years, like it will start from the 1965, and the price will start from like you can see the lowest price is the 1 and the highest price is 3 rupees 20 paise. Similarly, the year is the lowest is the 1965, and it will like a 2020. So this is the basic data. So we can assume like this is the price of the chocolates. So let's the in this data clearly we can see the an increase like a price. You can see the 1 rupees 120.40. So in this data we can see increase of the 20 cents in the price every 5 years, and this is a linear increasing trend. So this is called a linear increasing trend. So linear because it increases with the same amount every year, and increasing because it becomes more rather than less, right? So let's get this data into Python. to see how to plot this linear increasing trend using the source code for you can use like I have created years is the one variable, another is the prices, and second df has a data frame pd dot data frame year means years and price as a we want to see a price, and now I am going to the df has been plotted. So it's look here, it has been plotted, and df data structure we can see this is a pandas data structure look like this. So after that I want to plot this data, and you could see df dot plot like x as a year, and if you want to see like a y as a price, so you could write here plot x in a year and y as a price. So like this y will equal to like a price. So it can intimate like a y can represent it as a price, so it's not a being the price. So let's keep the one variable like the something here. So y is having okay because x has been represented like a, and so y we can prices. So let's try like this y will equal to like a prices. I think no it's looks so x has been plotted like a year and y has been like a prices. So it depends on the what do you want to the plot here, and if I do not write this one, so only you can see like a x-axis can represent this way. Second thing, just I have already plotted, so we can see easily this is the linear relationship. Now, so if we have a like a coffee price, so we can write here the coffee price over time, and we can create linear relationship between year and price. Now after that another data, so let's see first I am going to predict to the price. First we have already price of copy this hypothetical term, so you could just put your uh, like a ruler next to a graph and continue upward line. So the predict this variable doesn't need to the explanatory variables other than it's the past value. So the historical data of this example allows you to forecast the future, and this is determining characteristics of time series model. So now let's see in this data like a season, name of the seasons, so comparable example but with the price of hot chocolate rather than the price of cup of coffee, and quarterly data rather than data every 5 years. So period, and one is the season, another is price. So hot chocolate price, and now So here we can see the trend in the case of hot chocolate. So you do not have a year over year increase in a price, but you do detect seasonality. So in the example, hot chocolate price follow the temperature of the seasons. So let's get the data into the Python and how to plot the seasonal trend. So just one is the season, another is price. And now I am going to plot this data. So df panda dot data frame seasons, and you could see here like your data is this, and now we have plotted like this hot chocolate price over time. So you could see like your price has been plotted like this. You can see the season and it is a price. So in this plot of the hot chocolate price, so as in the previous example, we can predict the future price of the hot chocolate easily using the past data on hot chocolate price, and price depends on the only the season and not influenced by any explanatory variable. So try to understand univariate time series model makes predictions based on trend and seasonality observed in their own past. Do not use explanatory variable other than the target variable. So variable that you want to forecast. So if you like you can imagine some numerous type of combinations of those two processes. For example, have both a quarterly seasonality and a linear increasing trend and so on. There are many type of process that can be forecasted by modeling the historical values of the target value. And after that, like I have already imported pandas matplotlib, and one more thing just you can also try to understand like supervised machine learning. So just I am familiar with the idea of using the past of one variable, and I am going to discover a different approach to making a model. So we have just seen a univariate time series model which are that use only the past of the variable itself and to predict its future. But sometimes this approach is not a logical process, do not always follow trend and seasonality. Some predictions that you would want to make may be dependent on the other independent sources of informations, explanatory variable. So in those cases, we can use a family of method like this is called supervised machine learning, and it allows to models relationship between explanatory variables and the target variable. And similarly we try to understand like some example like a supervised machine learning approach. So to understand in this case we have the different data like a fixed data, and new example like a contain like a sales amount of the company per quarter with a 3 years of historical data. So 3 years of the historical, look here, This is the data. So 18, 19 and 20, 3 years of the data. And to get the data, and like one is the quarters, another is the cells, and third is like a create data like a pandas dot data frame and quarter, and I am plotting this data like this. So cells per quarter, you could see in this I have plotted the quarterly cells. So what we can see in this graph does not resembles the previous example. There is no clear linear relationship. Yeah, otherwise you can say there is no clear linear trend. So neither increasing nor decreasing. And there is no clear quarterly seasonality either. But as the data is about the cells, you could imagine many factors that influence the cells that you shall realized. So let us look for explanatory variable that could help in explaining a cells. So the data have been updated with the two explanatory variable. One is, let's see, so I have updated like a data like a discount, and another is the advertising. So you can see like include the sales numbers and advertising budget, both potential variables, and your new data could see like this. So getting a quarterly sales, and now I am going to plot new data. So if I am plotting this new data, so you could see here, like look here, one is the sales, another is the discount, third is the advertisement. So this gives you the graph that is displayed in this figure, graph displaying the development of the three variables over time, and plot of the sales per quarter with correlated variable, so you can easily get a correlation. So at this point visually you did probability say that there is not a very important relationship between the three variables, but let's have a more zoom and in look at the same graph. So let's see, just I am changing the something in this data, already quarter, second is sales, and third is discount. But I am going to the discount underscore scale adjusted like x multiplied with 10 for x. What is the x in discount? So let's say discount multiply the 10, and advertisement. So advertisement scale adjusted will equal to divided by the 10. Now after adjusting this data, because one value is the very large, one value is the very small, so machine learning models cannot will predict like a better way. So let's see, now we can arrange, and now I am going to the right data, pd dot data frame, quarter, quarters, sales, sales, discount, discount per scale adjusted, advertise, advertise per scale adjusted, and your data will be seen like this. Now you could see the relationship between among sales, discount, and advertising. So this gives the graph displayed in this figure, and you can suddenly observe a very clear relationship between the three variables. So the relationship was already there in the previous graph, but it was not visually observed due to the difference in scale of the curve. scales of the curve. So we observe the correlations is strong, and if you had to do this sales forecast for next month, you could simply ask your colleague what the average discount is going to the next month and what next month advertising budget is, and you would be able to come up with a reasonable guess of the future sales. So this type of relationship is what you are generally looking at while doing supervised machine learning intelligence. Use of those relationships is a fundamental idea behind the different techniques that you will see in the future. So I hope it will be clear, and then after that we will see here like in this data correlations. If you want to see the correlations, so correlations visually way to detect the correlations is a great. So if there is a more exact way to investigate relationship between the variables, the correlations coefficient like a Pearson correlations other. So the correlation coefficient is a very important measure in statistics and machine learning, as it determines how much two variables are correlated. So the correlation coefficient between the two variables x and y can be computed as follows. Correlation matrix is a matrix that contains the correlation between each pair of variables in a data sets, and to obtain the correlation matrix. So just you can see these are the correlations. So where is the better? So correlations is the near about 1 is called positive correlations, and if you go the -1, it's a negative correlation. So correlations coefficient always between it lies between -1 and 1. So positive value for the correlation coefficient means the two variables are positively correlated, and if the one is the higher than the other, generally also is the higher. If the correlation coefficient is the negative, there is a negative correlation. So if the value is a higher than the other, generally the lower this directions of the correlations. So strength of the correlations that is the close to the 1 and -1 is strong. 1 is the strong, -1 is also strong, but it's a negative. And 0 is a weak correlation, so strong correlation generally more increasing and explanatory variable, strong correlations variable. So let's see, all are the strong correlations. Only you can see the relationship between discount and sales is not a more. Other distinct machine learning models like complete a big picture overview of the machine learning landscapes. There are the few more groups you need to mention, like one is the supervised, another is the unsupervised. So you can see what the supervised model are all about, like but there are also the unsupervised model. Unsupervised model is different from all approach. We will discuss in the future. Before, there is no large target variables in unsupervised model. Unsupervised model are the great for making a segmentations. Like a classic example is the regrouping customers for a store based on the similarity of those customers. So there are the many great uses cases in the such the segmentations, but approach is not as generally useful forecastings. In future we will try to learn classification and regressions model. So thank you for today. Thank you very much. I hope someone is helped this video. Thank you.